So for question number 7, I'm going to start by drawing a diagram. So on the left, the y-axis, we have the intensity of radiation. And then on the x-axis, we have wavelength. So classical physics had assumed that the intensity of radiation emitted was a function of wavelength. So they proposed a curve like this. So at a particular temperature, as wavelength increases, the intensity of radiation decreased. Now, because UV radiation has such short wavelength, going by this idea, the intensity should be incredibly high, infinitely high. So this was called the UV catastrophe. Now, Planck, he proposed this idea that the exchange of energy between matter and radiation occurs in quanta. So he proposed a series of curves that look like this. So each curve represents a different temperature. The lowest curve represents a lower temperature. The highest curve represents a higher temperature. Now, he proposed the idea that radiation can only be generated if the oscillator, so the electron or the atom, has acquired a certain amount of energy. And so this energy, remember, is related to frequency, which is related to wavelength. So this energy can then be used to start an oscillation. At low temperatures, there's not enough energy, so then you can't cause any high frequency oscillations. However, as temperature increases, you'll now have intensity peaks. And now this means that you'll have at a certain wavelength, so then a certain energy, you can generate frequency oscillations. However, Planck proposed that on the left of these peaks, at these shorter wavelengths, the intensity of radiation will actually decrease, that there's not enough energy to stimulate even higher frequency oscillators.